Hello there, ROS Developers, and welcome to this live class number 111, where we are going to be talking a little bit about about node composition, in ROS2. So let's go for it. Alright, so hello there, ROS Developers, and welcome back to this live class, where we are going to be talking about node composition. So yeah, first of all, I want to confess that I'm not an expert at all in this node composition concept. So I'm still learning and testing things on it. So yeah, basically I'm going to share with you today, and I want you to practice with me a project that I have created, where we are going to be running some demos. We are going to create as well a component. So yeah, let's go for it. Let's not lose any more time, and let's go for it. I would like also to let me know. So tell me if everything is fine, image is fine, sound especially is fine. I have done some modifications here in the setup. So as for what I can see here, everything should be working fine. But I would like you to confirm it to me so that I can keep going normally. So let me know if image is okay, sound is okay. For now, it's fine. Everything is fine. Says there Capute. Okay, great. I can see there Gray saying hello, Florence from Singapore. Hello there, Florence. Okay, so I would assume that everything is working as expected. Then let's keep going. Okay. Yeah. Okay, so let's keep going. Then, let me know, guys, are you new to this live class? Have you already been in previous ones? Let me know also this. In any case, the process is going to be the same as always. So I'm going to start now by sharing with you the project link for today's live class so that you can copy it into your workspace. Looks good in Massachusetts, says Tom. Great then. So yeah, I'm going to start by sharing with you the project link so that you can have it into your workspace, and you can open it and you can practice and reproduce everything that I'm going to be doing during this hour. So yeah, let's switch right now to my computer screen so that you can understand all this better. Let me just get here a drink of my magical potion, and let's go for it. Alright, so let me switch here to my computer camera. Then here I am in my courses screen. There we go. So here I'm in the construct main page, let's say, where I have all the courses up here, ROS Development Studio. Then first thing I will have to do is to copy the project into my own workspace. So let me grab it here, and I'm going to paste it. In my case, for instance, I'm going to paste it here in the URL here in the bar, and this is going to automatically copy the live class project into my workspace. I'm going to show you right now. So as you can see, this has copied right now this project, which is ROS Developers Live Class number 111. It has copied this project into my workspace. Yes, as you can see, it's for node composition with ROS2. So basically what I'm going to do right now is to share this same link here in the chat. Let me try to find it. Here I have it. So let me copy here so you can have it. Then, so with this link, all you have to do is to log in into the construct. In case you already have an account, just log in. In case you don't have an account, just create it. It's going to take you a few seconds and it's completely free. Then once you are logged in, you are going to find here the My ROSjects space. Here is where you are going to have all the projects that you create or that you get by copying them to your workspace, like this one I have just shared with you. Maybe this is empty in your case if you don't have any projects yet. In my case, I have some here that I have been working previously, but probably this is, well, for sure this page is going to look different for you, depending on the projects you have here. But the case is that once you click on that link or you copy it here in the URL bar, whatever, you're going to receive here in your projects area this project for today's live class. Yep. ROS Developers Live Class number 111. Node composition with ROS2, which is today's topic. Alright, then once you have this project, in order to open it, all you have to do is to click here in the Run button. And this is going to automatically open the project. It shouldn't take too long to load everything. As you can see here, it's automatically loading a Jupyter notebook, which will contain some instructions to follow for today's live class. So let's give it some time to load this. Meanwhile, maybe I would like to talk with you a little bit as well about the other parts we have here in the construct. So mainly here at the top you can access the courses. You can see the different courses that we have. During these last days we have been working on porting the most important courses from Kinetic to Noetic so that we are up to date with the latest ROS versions. So yeah, you are going to find out during this week that the most important courses, ROS Basics, Manipulation, Perception, all these ones are going to be published in Noetic version, which implies some changes, some updates basically in the courses. Also, a new course in ROS2 navigation, which is already based in ROS2 Foxy. Also, we have updated the ROS2 basics course from Eloquent to Foxy. So many updates going on during this week in the platform. So have a look at it, and many more coming. So stay tuned, guys. You can access here in case you don't know which courses you should take. Here you can see all of them. You have them divided by categories: basic ROS, artificial intelligence, manipulation, navigation, whatever. You can organize them as you prefer. You can check also the learning paths here in case you want to get a specific note. For instance, if you are a beginner, I would suggest you start with this path, which includes some courses already packed for you, let's say. You can also access past live classes. Whatever, you have many options here, so have a look at them. And let's come back here. So, all right, here, I don't know why this hasn't opened directly the notebook. In any case, I'm going to, this should open automatically the notebook. In case it doesn't open automatically, just click here on the default, and this is going to open the notebook for you. Here we have them, here we have it. Let me try to close it and reopen it or something. Let's see if this opens it automatically. Yeah, here we have it. Yeah, so this is the normal behavior. So it should open automatically here the notebook in the Jupyter Notebook window. And you should have here the ROS Developers Live Class number 111 notebook. Then, yeah, so here we have all the instructions that we are going to be following in today's live class. So have it opened at all the times, in case you get lost, whatever, you can check the notebook, because I'm basically going to be following all the instructions that I have here in the notebook. Then, yeah, so let me know if you have copied the project properly to your workspace and you have been able to properly open and launch this project. Let me know here in the chat so that I can see. Goku Rush says done. Okay, I assume that you have already copy the ROS to your workspace, go cool, and open it. Let me know, guys, for the rest of the chat, if you are on track with me. It's working perfectly. Says go cool. Okay. Okay, great. Then let's keep going. So the first thing we are going to do in this case is to start the simulation. So for this, we are going to execute some commands, as you can see here. Then let me very quickly open here a new shell. You have the option here in the bottom bar. You have all the options like the web shell, code editor, notebook, to open the gazebo window, etc. I'm going to open, in this case, a shell and make it a bit bigger. Let me place this here for now. Then the first command I'm going to execute is the source. So basically here what I'm doing is to source the ROS version I want to work with, which in this case is Foxy, ROS2 Foxy. Next is I'm going to source the simulation workspace. This workspace I have here, simulation_WS, which basically is the workspace that contains all the simulation related packages. If I open here the IDE, which I'm going to do now, by the way, and make it a bit bigger, here you are going to be able to see all the yeah, so here you are going to see all the workspaces that all the different workspaces. In this case, the one we are sourcing here, as you can see, it's this one, simulation workspace, because it's the one that contains the Turtlebot 3 simulation for Foxy. So that's why I need to source this one. And then finally, what I'm going to do is to execute this script, which is inside this T3 Foxy folder. So I'm going to need to come here, cd simulation workspace src T3 Foxy, and here I'm going to find some simulation related packages, as you can see, and also I have different scripts which are going to launch different simulations related to the Turtlebot 3 robot. In this case, the one I'm going to launch is startsim.sh, which is going to launch, as you can see here, the Turtlebot 3 robot in an empty world, in an empty space. Then we can have a quick look, if you want, here to this script. But basically here, as you can see, we are doing some sources related to gazebo, and as well we are setting some environment variables here also related to gazebo, basically in order to indicate where gazebo is going to be able to find all the models, all the Turtlebot 3 models, so that we can visualize the robot in the simulation, right? Then, yeah, and at the end, basically, I'm going to execute a ROS2 launch command in order to start the simulation. So pretty simple. Then let me copy this command from here and launch it here. It's very important that you are here. You need to be in the folder that contains the script. Otherwise, this command is not going to work. So keep this in mind. Then I'm going to execute this, and this is going to start launching the simulation. And now, in order to visualize it, all I have to do is to come here and click on this kind of cube that I have here, which is going to open the gazebo window so that I can visualize the simulation. Let me make it a little bit bigger. There we go. And there we go. So here I have my Turtlebot 3 robot loaded into an empty world. Great. So I'm ready. I'm set up. I have started my simulation here in this shell. I have the notebook here opened and ready to start following it. And I have also my gazebo simulation launched, and I can visualize it here in my gazebo window. So basically, I would like all of you guys to be in the same point as I am here, so that we can start working and we are all of us in the same page. As I always say, I'm very repetitive with this, But I like you to be proactive in these live classes. So I don't want you to just sit there listening to me and watching what I am doing, but I want you to be practicing with me. This is why I share with you this project, so that you have it, you can open it, and you can practice and touch and modify things and test with me, because this is the way that you are going to really learn and grasp all the concepts that we are going to be covering today. All right? Then, so let me have a last look here at the chat. Simulation doesn't come up when I run a script. Okay, let's wait a few seconds. Sometimes it takes some seconds to load everything, depending on connection, on the instance, on where you are in many factors. It can take some seconds to show up, so let's just be patient. I'm going to wait for a minute or so. So if the command has loaded like this and it has started printing things and so on, if you didn't get any blocking error here when launching this command, it's just going to be a matter of time. It's going to, maybe it takes a bit longer for you to load everything, to render the models and everything, but it should load at the end. In case you are getting some kind of error here, let me know. Can we have material of this? Says Mudasar. Yeah, so this project, you can keep it. You are going to have it forever, let's say, in your workspace. So you can access it tomorrow if you want, next week, and modify it and do things there. So this material is for you. Waited a couple of minutes. So, but are you seeing something, Zach, in the gazebo window, or are you seeing nothing at all? So I mean, are you seeing the ground plane, this grid here, and you are not seeing the robot, or are you seeing nothing here? Are you getting any error here in the shell or something? Okay, let me redo the process. So what I'm going to do now is to kill this. Let's see if this fixes the issue. So let me stop it. Now, yeah, so now if I start to run it, if I try to run this again, I'm going to get an error complaining about gazebo. It's already in use. Yes, this is normal. So in this case, what we need to do is the following. We need to manually kill the GC server process. I can do this like this. PS Faux grep GC server. Let me copy this command here in the chat. If you run this command, you are going to find here the process where GC server is running. You can see it here, and this is the process ID, the process ID number, this 947 in my case. Then what I'm going to do is a kill -9 of 947. So I'm going to kill this process manually like this, kill -9 and the process ID number, and this is going to kill this process. If I try to find it again, I'm not going to find it, and you're going to see that the simulation is going to stop. So now I'm going to be able to launch it again. Remember, very important to be in the T3_Foxy folder in order to start this script. And we are going to run this script, start sim.sh. Right? You have it here in the notebook. Start_sim.sh. So let me run it. Start underscore sim.sh. There I go. I'm running it again. Let me wait here some seconds, and here I have it. So in case it didn't work, this is the process you should do. Okay. Zach, it's fine now, says. I had to select open gazebo from below. What? Here, you mean? Yeah, it's not necessary. You can just click here. You can directly click here in the cube, and that's it. You don't have to select any of these options. Just click directly here, and this is going to open this window. By clicking here directly in the icon. Working. Okay, great. So we have solved the errors. So let's keep going. Okay, excellent. All right. So we are ready to keep going. Then today we are going to be talking about node composition with ROS2. So as I have said in the introduction of this live class, I'm not an expert at all in this. So I'm basically a student also. I need to learn much more about how this node composition works and many things. But basically, don't take every work that I say as the holy bible of this. But basically, as per the tutorials I have been checking and so on, we can kind of compare ROS components in ROS2 with nodelets. So in ROS1, we were able to write code either as a ROS node or as a ROS nodelet. If you have been working in ROS1 already, you probably will know this. Then ROS nodes are compiled into executables. This happens as well in ROS2. And ROS1 nodelets, on the other hand, are compiled into a shared library, which is then loaded and run at runtime by a container process. So, if you have already been working with ROS1 and ROS nodelets specifically, you already have this idea. Then ROS components are kind of similar to ROS nodelets, are the equivalent, I would say, in ROS2 to ROS1 nodelets. Why? Because we can create programs and compile them as executables, also in ROS2, but we can also create these components in ROS2 which are not compiled into executables, but are actually compiled into shared libraries as well. And then they can be loaded also at runtime. So this is the main idea of ROS components, is to generate shared libraries that can be loaded at runtime. So in ROS2, the recommended way of writing your code is similar to a nodelet. We call it a component. So this is basically the way that the ROS2 community recommends to create your programs, which is by using components. Then this makes easy to add common concepts to existing code by making the process layout a deployment decision. Thus you can choose between running multiple nodes in separate processes with the benefits of this case, and running multiple nodes in a single process. So this gives the ability to run multiple nodes in a single process. We are going to see this in a moment with the demos. Then this is also important. So since a component is built into a shared library, it doesn't have a main function. So in the typical way of programming with ROS1, especially, we are used to create our programs and then have a main function. Then in components, this is different. In components, since they are compiled as a shared library, we don't have to create a main function. Make sense? Then a component is commonly a subclass of a node. We are going to see this also in a moment. And since it is not in control of the thread, it shouldn't perform any long running or blocking task in its constructor. Okay, let's skip this. Yeah, so basically what we are going to do is once we create our component and we compile it as a shared library, we are going to start a generic container process, and we are going to call a ROS service, which is low node, which is offered by the container, of course, and this service is going to load the component specified by the passed package and library name, and start executing it within the running process. So all this, just saying it might seem a little bit confusing. So what I would like to do is, basically I'm going to divide the live class into parts. First, I'm going to run some of the demos that I have found in the official documentation page. Here I have left the link so you can check them. Here it's the official ROS2 documentation, and they provide some demonstrations. So I would like to start this live class by running some of these demonstrations, so that we can try to understand by practicing, by doing practical demonstrations, all these concepts which just by reading them might seem a little bit abstract and confusing. So I would like to start by doing these demos, and then at the second part of the live class, we are going to create a component of our own, which is going to interact with the simulation. Right, so we are going to try to create a component by our own, a custom component. Here we are just going to be using some of the ones which are provided by default by ROS2. All right, then let's start. Then the first thing we are going to do here. So well, first of all, I'm going to minimize this shell here because it's where I have the simulation running, and I don't want to be closing it or anything. So I'm going to minimize it, and I'm going to open a new one so that I can start working here from zero. Then the first thing, of course, is to source the ROS version I'm going to be working with, which is Foxy. And then, first of all, one command that I can use in order to discover available components is this one, ROS2 component types. So let me copy this command here and execute it. And here I can see all the components that are available by default in ROS2. You can see here talker, listener, server, client. These ones we are going to be using them here in the demos right now. But we have others. We have one here, for instance, for the Robotics state publisher, a depth image to laser scan, teleop to joy. So we have, by default, we can see here some components that are already provided by ROS. Come to image, show image, related to image tool. So these are interesting components, by the way. Then with this command, we can see all the available components that we have. What else? Then runtime composition. All right, so here we are going to skip for now the compilation part, and we are going to assume that we have already created the code and we have already compiled it. So now at runtime, we are going to be using these components. Let's say. So in order to be able to do so, what I need to do is to first start the component container, which is this. It's this generic container process that we were talking here previously. Then in order to run this component container, we have to execute this command here. Let me do it right here. ROS2 run RCL CPP components component container. Then we can verify that the container is running properly by executing this command, ROS2 component list. Let me open a new shell, source again ROS Foxy, and I'm going to paste here the command, no, not this one, but this one, ROS2 component list. Then here we can see that we have this component manager running, which basically it's this one that we have just started here. Yes, so basically with this command, ROS2 component type, we can see all the ones that we have available here for using, but this doesn't mean that they are running. They are just available. Then here, I am actually seeing the ones that are currently running, which is this one, the component manager, the one that I have just started here. Then once I have this container running, I can start loading components. And I can do so with the following command. ROS2 component load, I indicate the container, and then I indicate the component that I want to load. In this case, it's this talker component, which is contained inside the composition package. So this is the command. Let me copy it here and paste it. So ROS2 component load, then I specify the name of the container, which we have seen here that it's component manager, and then I specify the package and the name of the component that I want to load, which in this case is this talker. Then I press enter, and this is going to load component 1 into component manager container node as talker. Yes? So basically here we can see that this talker component is starting to publish some messages here. So basically this talker component contains a publisher, a ROS2 publisher that it is going to start publishing this message, hello world, into a topic. So basically it's publishing here into the, I think it's chatter, ROS2 topic echo chatter. There we go. Yeah, so this component, this talker component that we have just loaded here, basically contains a publisher that it's going to start publishing these messages, hello world, into the chatter topic. So now we have loaded already one component. Then we can load another component, for instance. Then the command that we are going to use is basically the same. ROS2 component load, the name of the container, which is component manager, the package, and the name of the component, which in this case is listener. So we have first loaded the talker, and now we are going to load another component, which is named listener in this case. Let me run it. And there it goes. Loaded component 2 into component manager container node as listener. So now, in my container here, we can see the messages for the talker and for the listener. Right? Makes sense? Then as we can see now, I don't know what, yeah. So let's run one more time now the ROS2 component list. And we are going to see that actually we have the component manager, which is the container, and it has loaded two components, the talker and the listener. Yep, makes sense? Then one interesting thing that we can see here is, if we, let me make this shell here bigger. I'm going to run a psfaux in order to get a list of all the processes that are currently running. And we can see, for instance, here, actually let me make this a little bit bigger. We can see we have here the start simulation process, which is running the simulation, GC client, some daemons here from the middleware, whatever. And here is where we have actually the component container running. And as you can see, we have one process here, which is the component container. It's this process here, 1491. And both the publisher and the subscriber are running under this process. This makes sense? Yes? So we have these two components which are running under the component manager process. So we have two running under one single process. This is different if, for instance, if we run the talker listener demo in ROS2 using the regular way, so generating the code, generating the executables, we will have one process for the talker and another process for the listener. So let me do a quick example here. For instance, I have here a command. I can generate an example here pretty quickly. grab here this command here. There we go. So for instance, let me show you this. So I can come here. Let me open a couple of extra shells. Source, opt, ROS, foxy, setup, bash. Actually, let me see if I can find Talker listener demo ROS2. Or publisher subscriber demo. Subscriber demo ROS2. Okay, yeah. Here we have our own demo, which I think we are going to be able to use. Yes. So here, for instance, we have this command that we can use that is going to act as a publisher. So you can see here we are going to publish in a topic. It's going to be chatter 2. A message like this one. So let me publish this, and this is going to start publishing here. And now I'm going to generate a subscriber with the ROS2 topic echo command as well, in a different shell here. Source, opt, ROS, foxy, setup, bash. Then I'm going to do the echo here. Sorry, chatter 2. It's chatter 2. There we go. All right. Then here, if I run the psfox command, I'm going to see some things. Here I can see the component container, which it's running the talker and the listener in one single process, in the process of the container. And down here I can see I have the talker, which is running in this process, and I have the listener, the echo, which is running in a different process. So we can see here a difference and a use of this node composition in ROS2, which allows to load many components, different components, into a single process, right? So I wanted to show this. Let me stop all this now. There we go. All right, then let's go back. Let's go back up here where we left it. Runtime composition. Okay, yeah, component. We have been loading the talker and the listener. Yeah, so here as well we have been using it for loading. Let me stop it here. So here we have used it for generating a publisher and a subscriber, but we can also use it for services, for instance, for loading a service server and a service client. So this here we have another demo that we can use right now. We can load here the server. There we go. And we can load as well the client, right? And this has generated the server and the client. We have the server and the client which keeps calling and receiving the answer from the server. We can run as well the ROS2 component list. And we are going to see that we have the container with the server and the client. So this works for services, for topics also. So yeah, let me stop this demonstration and let's keep going. So another example we have here, which I'm not going to go too deep into this because there are different. So one thing we have not explained it here or not gone over is that there are different ways of working with components. So yeah, the composition package contains a couple of different approaches on how to use components. Then the three most common ones are the one we have just used, which is to start a generic container process. and then call the load node offered by the container. So we start the container and then we load the components manually, which is the way that we have done right now. A second one is to create a custom executable containing multiple nodes which are known at compile time. Then this approach requires that each component has a header file, which is not strictly needed for the first case. And the third option will be to create a launch file and use ROS2 launch to create a container and load the components. So we have these three options. We have already seen this one. And then the second one, it's this one, which is to create a custom executable. Then I'm not going to go too deep into this one, but let's just run here the example, which we have already here created this manual composition, which is an executable. Let me copy and actually directly copy and paste this command here. And as you can see, this is loading all 4 components at once: the talker, the listener, the server, and the client. In fact, here now, if I run the ROS2 component list command, I'm going to see, I'm not seeing any. All right, yes, because, yeah, of course, yes. So this demo shows that the same shared libraries can be used to compile a single executable, because they are running on an executable in this case. Running multiple components. The executable contains all 4 components from above: talker, listener, as well as server and client. So basically, with this example, we have generated an executable. So we are not using this container. We are generating an executable, which it's going to start all 4 components. You can have a look here if you're interested in. I have left here a link where you can see basically the code of this option, which is this manual composition CPP. And you can see basically here how we are adding the nodes: talker, listener, server, and client. Also, you can have a look here in the composition folder to the CMake list, and you are going to see how this executable is generated. Here you have it. The manual composition executable. It's an executable. You will see now that the example that we are going to create, it's not going to generate any executable, just a shared library. But in this case, we do generate this executable from this CPP file, and then we target the link libraries, which are the talker component, listener component, server component, and client component. Right? Makes sense? So this is the second approach, which I wanted just to show it a little bit here from just an overview, so that you can test it, and you can then come here and check more details if you want. And then the third approach, because obviously for time reasons we don't have time to check this into too much detail. Probably we are going to do in the future more live classes on this, because I have much more to learn, and I think it's a super interesting concept. So we will do more live classes in the future, going more deep into different options. Then the third option is to use a launch file. So here we have a launch file, ROS2, with the command ROS2 launch composition and composition demo launch py. So basically this is going to load. Also, in this case, it's loading the talker and the listener. And if here, in this case, if I do the ROS2 component list command, I'm going to see the container and the talker and listener. Why? Well, because let's have a quick look here at the launch file, what it's doing. You have the link here in the notebook. Basically, here what I'm doing is to start the container. As you can see, I'm starting a container, and then I'm launching the components here. First the talker, and then the listener. So basically I'm doing the same as the first approach, but from a launch file. Yes? This is why, in this case, I am actually able to see the container with the components inside it. Then, alright, so we have seen, we have tested here the 3 different approaches to work with. There's there is some more options in the official tutorials, but it's already too much. So I wanted to try to keep this to the basics because it's the first live class that we are doing on this. So I try to not go too much into details. Then we have seen the three main approaches. Then another option interesting is that the same way we can load components, we can also, of course, unload a component super easily. Let's first launch the container here, the generate container. Then, of course, we are going to need to, well, we can run here the command. We are going to see that it's empty. We have just the container. Then we can load here the talker. Then we will have the talker here. Of course, there we have it. We can load as well the listener, which is going to now show me both of them, the container with the talker and the listener. And as you can see, they have a number here associated. Then what I can do is to unload them. How? Where? Super easy. By using the command ROS2 component, and instead of load, unload. Then I specify the name of the container, and now I specify the number of the component that I want to load. For instance, here I'm saying 1 and 2. So I'm going to unload both components, the talker and the listener. Then if I execute this command, and I do the ROS2 component list, I'm going to see that now I have removed both components and I have only the container. Yep, so very easy way to unload components. The same way we can load them, we can also unload them very easily at runtime, everything at runtime, as you can see. And finally, there is another interesting tool, which is remapping. So we can remap both the container and also the components. So for instance, let me grab here let me stop this container and relaunch it. Oops, I have not copied it properly here the command. There we go. So this is the command in order to load the container as we have been using. Here, ROS2, I have already too much logs here. But yeah, here we have here it is. So this is the regular command, ROS2 run RCL pp components, component container. Then basically I can execute the same command, ROS2 run RCL cpp components, component container, and then I can pass the following arguments in order to rename this. Right? So in this case, I'm renaming the node from component manager to my container, and I'm also adding a namespace here, which is this one, namespace. It can be anything. You can change this, either the name of the container or the namespace to see how it affects. But basically, we can run this, and now, if I run the ROS2 component list command, I'm going to see that my container has this namespace that I have specified here, and it also has the new name, which is my container. Then, as well as remapping, let's say, the container, we can also remap the component names. We can also remap the component. Yes? So this is done also super easily. Let's launch the container in the regular way without remappings. And now we can see some examples here of how to load the components using these remapping tools. So ROS2 component load, the name of the container, the name of the package, and the component to load. And then I can modify here, for instance, the node name. So I'm going to change the node name. Instead of being Talker, I want to rename it to Talker2. So now, if I run the ROS2 component list, I'm going to see the name here has changed to Talker2. In the same way, let me run all of them here at one moment. So let me copy now the second command, which is this one, ROS2 component load, name of the container, package, name of the component, and here in this case what I'm doing is to add a namespace. So if we run the ROS2 component list, I'm going to see a second talker which has a namespace. In this case, in the first case, I have renamed the node name to talker2. In the second case, I have added a namespace, but I have not renamed the node name. So that's why here it's talker, because I have just added a namespace, but I have not modified the node name. And finally, I can also, of course, do both things. So I can change the node name and I can add a namespace. Let's execute the command and see the output here with the namespace and the rename of the node name. Yep, makes sense. All right, then let me stop this. I will stop the container so I don't have any component there. All right, then having shown all these command tools, all these options, different approach on how to use components, I hope you have a better idea of what components are and especially how they can help you. So it's a tool that can be super useful in ROS2 in many ways. For instance, it provides this ability to run different components into a single process, which is going to optimize, of course, communications, etc. Then, having done all these demonstrations and having seen the basic command line tools in order to interact with components, how to launch the container, how to load components, do the remappings, etc., and different ways of launching components. We have seen the manual one, this one, executing the commands. We have seen using the launch file, and we have seen creating an executable that also loads these components. Then now what I would like to do, we have only 5 minutes left for the live class, so I don't know how we are going to do this, but I'm going to try to do it as fast as possible. I would like to create our own component. So in order to do this, let's create a package, and I'm not going to need to source because I have already some shells here sourced. Then I'm going to come to the ROS2 workspace SRC folder, and here I'm going to create a new package. Let me copy the command directly from the notebook and paste it here. So ROS2 package create, I'm going to name the package LC components, so live class components. The build type is CMake, and as dependencies, I'm adding RCLCPP, RCLCPP components, composition, and geometry messages. So all these packages, I'm adding them as dependencies of this one. Then let me execute this command, and this is going to create here in the ROS2 workspace. Here is going to create a new package. Here we have it, LC components, which is empty for now. Then inside here, I'm going to create a CPP file, which I'm going to name moveRobot_component. So let me come here, create this new file. Inside the SRC folder, moveRobot_component.cpp. There we go. And then here what I'm going to do is to copy and paste the code I have here in the notebook. Let's do it. And let's have a quick look into this. So basically, I'm going to go fast. You can review it later if you want, because we are super short in time. Then, as always, nothing new here. So basically, we are including some models that we need. There's CLCPP, twist method. It's actually the one we are going to use. So let me advance that this component, I have created it in order to move the robot. Then here, as you can see inside the component, so here what we are going to create a moveRobot component here that subclasses the generic node-based class. You can see it here. Then, as we have already said before, components get built into shared libraries and as such don't write their own main functions. Oops, something here. And the process using the component shared library will instantiate the class as a ROS node. Then here we are defining the component, which it from the subclass node, as we can see here, and we are naming it the node, in this case, MoveRobot. Then inside here, we are creating a publisher, which is going to publish twist messages into the command bell topic. We create the timer, and inside the timer, we generate a message of the type twist. We fill this message with a linear x velocity and an angular z velocity, and then finally we publish the message. So this is basically, the code is super similar, as you can see, as a regular publisher from CPP, but the thing is that we don't have any main. So what we are doing here is to use this macro from RCL CPP components in order to register. Here what we are doing is to register the component that we have just created. We are registering this component, LC components move robot. This is going to be the name of my component. LC components move robot. So here I am registering. Yes. Then another thing that we can see here is that I'm including a header file, a super basic header file. So you have it down here. I'm going to just copy the code from the notebook. Oops. Let me come here and copy the code. And I'm going to generate inside the include folder LC components. I'm going to create here my header file, move, which is going to be named move robot underscore component.hpp. This is a header file, and it's super basic. So here we are defining the name of the class move robot, which inherits as well from the node class, and we are basically defining some things like so here we are defining the timer variable, the poop, etc. So just a very basic header file. Then we have one more thing, which is to create this visibility control.h file. This file, we are going to create it inside the include folder LC components as well. So let me create it here, visibility control.h. Important. So the header file from the MoveRobot component, it's HPP. So the source file is CPP and the header file is HPP. This one, it's going to be named visibility underscore control.h. This file, you have it also here, the contents, just copy and paste it. And this file, actually I'm not 100% sure of if it's needed or not. In any case, in the demo codes I have been checking, they are using it, and you can see here why this is being used. In theory, this is improves load times, as you can see, of dynamic shared objects. So it's going to improve loading times of shared libraries. This visibility control.h. So that's why I'm adding it. So in general, I would say that it's going to be recommended to add this file as well, visibility control, because it's going to optimize the loading times of the shared libraries. Basically, it's what a component is. So with component, with raw composition, what we are doing is to load shared libraries. Then that's why I have added it. I'm not sure if this is mandatory, probably not, but I have done it because I always try to show the recommended way of working, and this looks to me as something which should be the way to go. Then if you want to know more details about this as well, I have added a link here. You can check it to see specifically how this works and what improvements it's going to provide, etc. You can check it by your own later. Then finally, what we are going to do is to compile. So we are going to need to compile, but before compiling, we need to do some modifications to the cmakelist txt file, as always. Then let's open the cmakelists. Then the first thing we are going to do is to include the directory included here, because we have added some files here. So we need to make sure that this gets compiled. I'm going to add it here, for instance. Include directories include. All this is going to be added to the cmakelist file. Then next we have this block of functions, the middle one, which I'm going to copy and paste also down here. And here is basically where we are generating the library, as you can see. So we are calling this add library function, which is going to generate this library as shared from the move robot component CPP, from the C++ code that we have created here, the one which creates the publisher, which publishes into common belt topic, etc. Then so we define some dependencies as always, RCL-CPP components. We have to as well register the nodes. Yeah, so basically here what we are doing is this. So we are generating the shared library and defining the dependencies and finally registering this shared library, registering the nodes in this case. Then finally, what we are going to do here is to install this library as well into our package with the install function. So we are going to install the move robot component into the following destinations: lib, as an archive in lib, as a library in lib, and as runtime in the bind folder. So we are going to first we generate the shared library, we set the dependencies and all the compilation options that it needs in order to be generated, and then we install it into the needed folders in order to be able to so that we can load it basically. Then alright, so once we have already modified the CMake list file, let's just compile. So I'm going to come here and compile using, as you already know, colcon build. Hopefully everything goes fine. We shouldn't have any problem here. Colcon build, this is starting to copy 50%. Okay, so this has compiled. Then let me source. Remember always to source after you compile. There we go. And let me come back to a notebook if we have something else. Okay, so now what we can do before testing it is to make sure that our new component has been properly created and generated. So for this, what we can do is to execute the ROS2 component types. Do you remember the first command we used, where we have all the available components? Now here we should see our new component, and we can see it actually here. So here we can see that now when listing all the available components, we have our component here, the one that we have just created. From LC components package, the move robot component. So actually it has been generated properly. So now that we have verified this, we can try to load it. Then what we are going to do is to first start the container, make sure that our container is up and running. Here we have it, and now what we can do is to load our component. Then when loading our component, what we should see is that the robot starts moving, because I'm going to start publishing into the command belt topic. Then let me come here to the regular commands we were using. Here we see. Okay, so now we need to modify this because our component is inside the LC components package, and it's named LC components, and it's named, how it is named? It's named move robot, right? So we are going to load into this component manager that we have just launched here, and from the LC components package we're going to load our component, which is LC components move robot. Yes, so we can see it here. LC components move robot. We have it also here where we registered our component. LC components move robot. So this is the name of our component. Yes. Then once I have updated the command, I can run, and as I have just said, this should start. This should first load the component, and it should start moving the robot. Failed to load. Okay, failed to load. Yeah, sure. Why it has failed to load? Well, very easy, because I have not sourced here the ROS-based. So I have compiled everything and sourced it here in this shell, but actually I need to source my workspace as well in the other shells. So let me source this and relaunch the component container, and I'm going to need to source as well this shell, ROS2 workspace, install setup bash, and now I should be able to find it and load it. There we go. So as you can see, we can see that loaded component 1 into component manager container node as move robot. And we can see here how the robot starts moving. And finally, we can see as well, running the ROS2 component list command, we can see that we have the component manager with the move robot component that we have just created and loaded. Right? Okay, excellent. So that's all, guys. So that's all for today's live class. We have reached, well, actually not. We have a final part here, which is to start it with a launch file. Actually, I'm going to run it super fast. Let me just run it super fast, and then you can check it later with more time. So let me, first of all, stop the robot and restart here the simulation. Well, basically not restart the simulation, but reset the robot's initial position. There we go, we have it at the center. And then, so we have, right now we have run it with the first approach, which is to manually launch the container and manually load the component. Here with the ROS2 component load command. Then here, very quickly, we are going to do the launch file approach. So we are going to generate here a launch folder, first of all in our package, launch. Inside the launch folder, we are going to generate a launch file, which I'm going to name move robot underscore component.launch.py. I know that I'm going fast right now, but you have all the code and everything here in the notebook, so you can check it now after the live class. Then I'm going to paste here the launch file code, super basic. So we are first loading the container, as you can see here, and then here we are loading the component, which is our component, LC components move robot. Then what else? So I'm going to need to install this launch file. So I need to add this section to the semi-list file at the end. Let me come to the semi-list file, and here I'm going to add this install folder, which basically is going to install the launch directory with all the launch files so that I can use it. Then, once I have done this, all I have to do is to recompile so that I get, sorry, not all, but only the ROS2 workspace. So recompile so that I generate and I compile this launch file, source, and now I can run it with the launch file, everything. I can start the container and load the component with the launch file. ROS2 launch LC. Let me make this smaller here and show here the simulation. So ROS2 launch LC components, and it was move robot component.launch.py. Then this is going to automatically load, start the container and load my component, and as you can see, it starts moving the robot. Yes? All right, excellent. So we are super past, already 12 minutes past the time, but well, I wanted to finish everything. So now, yes, now we have finished everything I have prepared here for the live class. So remember, this notebook and this project, everything, all this project, you are going to have it in your workspace forever, so you can keep working now after the live class. You can try to do some modifications to this component. You can create another component which does another thing. So yeah, please do it. Please try to keep working on this, exploring, testing things. That would be great. And yes, as always, thank you very much, guys. Thank you very much for being here with me another week in another live class. So without you, these live classes wouldn't be possible. So thank you very much for being here. I hope that you have learned, just even if it's been something small, that would be enough for me. But I hope you have at least learned something, and that you have enjoyed it and taken some profit from this hour and this live class. And yes, thank you very much. I will see you next week in live class number 112. And until then, as always, take care and keep pushing your ROS learning. Bye bye.
What are you doing, Alberto?
I'm training this intern with ROS.
Oof! Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises, a fast and easy way to empower your team with ROS. From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects. Want to become a happy Alberto? Request a demo today.